Last time we talked about sequences and series in general. Today we're going to talk about a specific type of sequence called the arithmetic sequence. And in the next section we're going to talk about another specific type of sequence called the geometric sequence. What an arithmetic sequence is a sequence in which you get each consecutive term by adding the same number to the previous term. Okay? So for example, if you start with 2, and if you add 3 each time, then it's 2, then 5, then 8, then 11, and so on. So you're adding the same number at each step. Another way to say that is that the difference between successive terms is a constant. That constant is called the common difference, and it's denoted by the letter d, lowercase d. So let's start off with a very easy example. We're given the beginning few numbers of a sequence here. We have to find the common difference and then find the next 4 terms of the sequence. So to find d, what we have to do is subtract 2 consecutive terms. And we always subtract the second minus the first. So A2 minus A1. Or A5 minus A4. Just like in science where you subtract the second minus the first, the final minus the initial. So in this case, it's going to be negative 36 minus negative 53. And that is 17. Now, to find the next 4 terms, all I have to do is add 17 to each of the terms. So we have negative 19 plus 17. That gives us negative 2. And then we add 17 to that. We get 15. And then you do 15 plus another 17, 32. Plus another 17, 49. And a sequence is always written in linear form with commas. Okay, so those are the next 4 terms. Any questions? All right. If we keep up with this reasoning, if you start with a value, let's say the first term of the sequence is 5. And if d is 3, then we're going to keep adding 3 to each of our terms, right? So we add 3, and the next term will be 8. And you add 3 again, and the next term will be 11, 14, 17, and so on. Now, this is the first term, so this is A1. This is A what? 2, 3, 4, 5. Right? Now, if this is A5, what's n?
5.
N is 5. Now, if n is 5, now let's count how many times we added a 3 in order to get here. I added a 3 once, twice, 3 times, 4 times. So even though I'm on A5, I add 4 3s, right? So if I'm at A63, how many 3s will I have added? 62, always 1 less, okay? I will have added n minus 1 3s. So that's where this formula comes from. In order to find a specific term in the sequence an, I start with a1 and I add to it n minus 1 d's. Okay, so that's how I can find a specific number. So if I want to find the 502nd term, I can use it. I can do it with this formula. We're going to be using this formula throughout the section today. And actually, it's a good idea for you guys to write the formula out each and every single time you're going to use it, so that by the time you're done with tonight's homework, you will have memorized the formula. Okay, so let's get started with this first problem. It says to find both an explicit formula and a recursive formula for the nth term. Okay, so no matter what the case, first I need to find D. To do that, I subtract A2 minus A1. So 3 minus 14. My D is negative 11. So at each step, I'm going to add negative 11. Now, to write an explicit formula, we're going to use this formula. So AN is A1 plus N minus 1 times D. Okay? So let's see what AN is here. It's A1, which in this case is 14, that's the first term, plus N minus 1, negative 11, I'm sorry, N minus 1, negative 11 is D. Times negative 11. We now distribute the negative 11. So it's 14 minus 11n plus 11. So AN is negative 11n plus 25. To find the recursive formula, the format is this. You first have to specify what A1 is. Then each of the other terms, so if you want to find AN, if I want to find the fifth term, then I take the term right before it, that's AN minus 1, and to that I just add my D. Alright? So using that, let's fill this in. A1 in this case is 14. Semicolon, AN is AN minus 1 minus 11. So now we have the explicit and the recursive formula.
Where'd that come from?
This is the recursive formula like we did in the last chapter, in the last section. To find the 41st term of the arithmetic sequence, again, we're going to use our same formula. So first we need to find D. That's A2 minus A1. 4 minus 11. So that's negative 7. Now, my formula is AN equals A1 plus N minus 11 times D. If I want to find A subscript 41, that's my 41st term, how much is N? N is 41. Okay, because I want to find the 41st term, that means that's A subscript 41, so N is 41. I plug in A1, which is 11, plus N, we said was 41, minus 11, times D, I just found out to be 7. Okay?
Minus 1.
Yeah. 41 minus 1. Okay. So what I have now is 11 plus 40 times negative 7. So A subscript 41 is going to be negative 269. Okay. The next few questions are going to ask us to find different elements in that same formula. So we're just going to have to reuse the formula over and over again. So let's see what we have here. It says find the first term, meaning we're looking for A1, of the arithmetic sequence for which A44 is 229, D is 8. All right, so if A44 is what's given to us, how much is N? N is 44. Okay? So we need A1. Let's write down our formula. A1 plus N minus 1 times D. AN is the value I'm given here, 229. equals A1 is what I need to find, plus 44 minus 1 times D is 8. So 229 is A1 plus 43 times 8, meaning A1 is negative 115. Okay. In this last question, I need to find D. Again, we're going to use the same formula. What are we given here? We're given A1. What information can I extract from here? Anybody?
N equals 38.
N equals 38, and what's that? What value is that?
AN.
So 56.5 is equal to 75 plus 38 minus 1 times D. At the end of the day, D is going to be negative half. And whether you say negative half in fraction or decimals, it makes absolutely no difference. If I take two non-consecutive numbers in a sequence, the numbers that come in between them are the arithmetic means. Okay, so for example, if I were to take 7 and 47 randomly, then the numbers that come in between them are the arithmetic means between 7 and 47. All right? What we have to do in this case is we have to write an arithmetic sequence in which we can insert 5 arithmetic means. Okay? So basically what we want to do is we have the bookends here. We have the first and the last term. We want to find the terms in the middle. So the way our sequence is going to look at the end of the day is we have 6.2, 5 terms, and negative 1.6. Okay? So what do we have here? I have A1, it's 6.2. This is A1. Now I have my second, third, fourth, fifth, sixth, seventh term. A7 is negative 1.6. That means, how much is n? If I have A7, that means n is equal to 7. Okay? So let's plug all this into our formula. AN is equal to A1 plus n minus 1 times D. So we have negative 1.6 is equal to 6.2 plus 7 minus 1 times D. Once I have D, I could just keep adding that same value to each of these and I can get the numbers in between. When I solve this equation, I get that D is equal to negative 1.3. So now what I have to do is add negative 1.3 to each of these steps and fill up my sequence. That means if I start here and I add negative 1.3, I'm going to get 4.9. If I subtract 1.3 again, I will get 3.6. I do it again, and I get 2.3. I do it again, I get 1. And one last time, I get 0.3, negative 0.3. So that's what the sequence looks like. Okay? And you would write as your answer all the numbers starting from 6.2 to negative 1.6. Now, if we take